In this video, we are going to discuss about the dynamic memory allocation in C. So before we talk about the dynamic memory allocation in C, first we have to know what are the memory allocation concepts in C. So when it comes to memory allocation in C, there are actually three kinds of memory allocation for the variables that has been supported in C. So they are the static allocation, automatic allocation, and then the dynamic allocation. So when it comes to static allocation, when we declare a variable as a static or a global variable, then the static allocation is done for that particular variable. So each variable has been allocated with some kind of fixed size of memory space. So whether it is a static or a global variable, so some kind of fixed size of memory space has been allocated. So the number of bytes reserved for this particular variable cannot change during the execution of the program. So until the program gets executed, the number of memory space that has been allotted for this particular static variable or the global variable, it cannot change until the execution of the program is done. So when we speak about the automatic allocation, so whenever we try to declare a variable that is of a local variable within a code block. So here when we talk about the code block, I have just given it with the name of the compound statement. So compound statement indicates about some kind of code block. It may be a function or it may be a while loop, or when you are trying to declare a particular variable within a section of code or within a block of code, then the space for that particular variable has been allocated, and the space has been released when we are trying to exit that particular block of code. So basically automatic allocation speaks about the memory space that has been available for the local variable. So whenever this local, when we talk about the local variable, it means that this particular variable has been declared and been used within one particular section of code or one particular block of code. So the third one is the dynamic allocation. So dynamic allocation speaks about the process of allocating the memory to variables during execution or runtime of the program. So today we are going to see basically about how you can go for the dynamic allocation of memory in C programming. So before that, we'll also try to understand how the memory is being used, or what is the memory usage that happens in C. So basically we have to understand how the memory is being used in the programs. So basically your memory is being divided into two, that is the program memory and then the data memory. So the program memory consists of the memory that is used for main and other called functions in your program. So whereas your data memory consists of the memory that is needed for the permanent definitions such as your global data, local data, constants, and dynamic memory data. So basically the way in which your C handles the memory requirements is a functionality of the operating system as well as the compiler. So when a program is getting executed, the main function and all the other functions are always kept in the program memory. So however, the local variables of the function that are available in the memory is only when they are active. So the data memory is active only when the variables are available. So apart from the stack, we also have a memory allocation known as heap. So heap is actually a memory that is in the form of the unused memory allocated to the program, or the available memory to be assigned during the execution. So if you have seen the concept of functions in the previous videos, then you might have awareness about the stacks and the heap. So basically, apart from the stack, we have a memory allocation called as heap that stores the unused memory that are yet to be allocated. So these are the different types of memory that we have in the memory usage. So basically the program memory, in order to execute all the main function as well as your other functionalities, whereas your data memory is something that is available only when your variable is there for getting executed. So next we are going to see about the dynamic memory allocation in C. So as I told you, the process of allocating the memory to the variables during the execution or the runtime is called as the dynamic memory allocation. So basically your let's say for example I'm declaring an array of size 50, and there is a chance that I can use maybe 10 to 20% of this particular available array memory space. So let's say out of 50, I may be using 10 to 20% of the memory space that has been available. So I may not be able to use all the 50 memory space, but I may be using either 10 to 20% of the memory space that has been reserved for this particular variable, that is array. So what means is I'm going to waste the remaining space. So in order to overcome this, so we are going to actually reserve the amount of memory that has been exactly required during the runtime, and that particular process called as the dynamic memory allocation. So instead of wasting the the unallocated spaces, what we are going to do is we are going to get the actual amount of memory that has been required in order to do your program execution. So this particular process is done during the runtime, and this is best in performance. I mean, this can give you the best performance in cases where the memory requirements are not known. Okay, so in your C program, there are actually 4 library functions to allocate and deallocate the memory. So the first one is the malloc. So malloc is going to allocate the memory space, and it will return a pointer to the first byte of the allocated memory space. So what happens is some kind of memory space will be allocated, and and this particular function is going to return a pointer, and that pointer will point to the first byte of the allocated space. So the first byte of the allocated space indicates about the address of the first element. And calloc, it also allocates the memory space for an array of elements, and it initializes them to 0, and again it returns a pointer to the first byte of the allocated space. That is similar to your malloc. So basically both these functions, malloc and calloc, they are going to allocate some, or they are going to reserve some memory space, and they are going to return a pointer to the first byte of the allocated space. So the third function is the free. So free is going to release or deallocate the memory space that has been already allotted. So basically using the malloc and calloc, we might have allocated some memory space, and that memory space will be released, or that memory space will be deallocated once the usage of the memory has been done, or once the program has been executed successfully, or when you are coming out of that particular program, you are going to release or deallocate the memory space. And the last one is the realloc. So realloc is going to modify or alter the size of the previously allocated memory. So maybe you might have used a specific amount of memory to be reserved using malloc and the calloc. So with the help of realloc, what we are going to do is we are going to change the size of the previously allocated memory that was done using the malloc and the calloc. So next we are going to see how you can allocate the memory block in C. So as I told you, malloc has been declared in the preprocessor directive, that is stdlib.h. So standard library. So it has been declared in the stdlib.h. So it reserves a block of memory of a specified size and then returns a pointer which is of a void data type. Now remember, this is very important. Here we are telling about the pointer that is getting returned of a void data type. So what happens here is I'll tell you the syntax, then you can understand, then we'll come to the explanation part again. So here if you see the syntax, I have given an assignment statement. P is getting P followed by a assignment operator, and here I have given a typecast followed by a unary operator star, and I have used the function malloc of size. So this particular statement indicates P is actually a pointer of data type typecast. So P is actually a pointer of data type typecast. So what do you mean by typecast? So typecast is basically going to be another data type, and your pointer P should be allocated, or your pointer P should be declared earlier of the same data type of the typecast. So here let's say for example I have I've given a memory allocation statement here. So let us take the right hand side first. So if you take the right hand side first, the memory allocation process, that is the memory allocation function, will be called first. So malloc will be processed. So malloc is getting processed with the input argument, that is 20 into size of int. So this particular statement means that first I'm going to get the size of the data type, that is integer. So integer has got a data type, integer has got a memory space of 2 bytes. So size of integer will have a value that is 2. So 2 into 20 will give me a numeric value of 40, and 40 bytes of memory space should be allocated. So your malloc function will reserve a block of 40 memory spaces, and then it will return a pointer. So that pointer will be of the address of the first block of the element. Okay, it will be the address of the first block of the element, and that particular pointer is going to be of a void data type. So malloc, it will actually reserve the memory space, and then it will return a pointer value, and that pointer value will point to the first byte of the allocated space, that is the first byte of the allocated space, and that allocated space is of a void data type, that allocated space of a void data type, and that particular value should be typecasted in terms of an integer. So here we are doing the typecasting. Okay, why? Because the malloc function is going to return a pointer value of a void data type. So why it is going to return the address in terms of a void data type? So always remember, the address returned by the malloc function is going to be always of the void data type. This is because malloc does not know what for did it allocated that memory location, for which data type or for which particular element the memory is getting allocated. So malloc will never know for which particular element or for which data type the memory is getting allocated. So remember your void star. So let's say for example your void is actually a pointer. So whenever we say that malloc returns a void pointer, it means that a void means actually a pointer which is a legal address, but it is not the address of a character variable or an integer variable or address of any other data type. So that is why we need a conversion or we need a typecasting in order to convert the void pointer to the corresponding data type your requirement is pointing to. So here what I have done is, array is actually a pointer variable. Again remember, array is actually a pointer variable, and this pointer variable is assigned to the memory allocation. So how the memory is getting allocated? First you are going to call the function malloc and you are going to specify the size. So it need not be always 20 into size of integer. You can even give a numeric value. That is not, that is up to you. Okay, so this particular function is going to reserve that much amount of memory space, okay, that has been specified as a size, and then it is going to return a pointer value of a void data type, and that has to be typecasted properly to the proper requirement that has been or whatever program has been trying to get intended to. Okay, so always remember, this typecasting is very, very important once the memory allocation has been done. So this typecast indicates about the data type to which you are going to point out to. So here what happens is, your memory is getting dynamically allocated 20 times the size of your integer data type. So your integer data type has got a size of 2 bytes. So 20 into 2, what happens? You are getting 40. Okay, so 40 bytes of memory space has been allotted in this particular statement, and what happens is, this space has been reserved and the address of the first byte of the memory. Okay, so that is the address of the first element. Okay, the address of the first byte of the memory is getting allocated and it is assigned to the pointer array. And always remember, your array that is present in your the left hand side, okay, it will be of the typecasting data type, that is integer. Okay, so remember, whatever typecasting you are going to point whenever the memory is going to be allocated, okay, the same typecasting data type should be declared for the pointer variable that is present on the left hand side. Okay, so this is the syntax, and I have given one example as well. So what happens is, for calloc as well, okay, the same kind of process is going to follow. Okay, so basically your calloc stands for contiguous memory allocation, that is used for arrays. So what your calloc does is, it is going to reserve the memory at the runtime and it is going to set all the bytes to 0. Okay, so the syntax is the same as we saw for malloc. Okay, so the only change is we are going to specify the number of entries that has been required and then the size. Okay, so basically your calloc receives 2 input arguments. Okay, so as I told you, P is a pointer of the data type typecast, and let's say for example here we have the same kind of allocation, that is your pointer variable array is been assigned to allocating the block of memory using calloc, where we are passing 2 input arguments. So basically here it should be n comma, not n star, it should be n comma. So n indicates about the number of elements and then the size of what is the data type that you are trying to look for. So basically here it should be comma, not star. Okay, so calloc n comma size of integer. Okay, so size of indicates about the number of what is the memory space that is being required for each and every element. Okay, and n indicates about the number of elements. Okay, so again your calloc is going to reserve the memory space. Okay, so it allocates n times the size of the integer data type. Okay, so 2n bytes of memory space will be allocated in terms of this particular example, because size of integer is 2 and that has to be assigned for n elements. So 2n bytes of memory space will be allocated dynamically. So all this process happens during the runtime. So whenever there is no memory space is allocated, then this particular function, both malloc as well as calloc, it will return a null pointer value. Always remember, whenever there is no memory space that can be allocated using the malloc or the calloc function, both these functions will return a null pointer. So this null pointer that is returned indicates that there is no memory space that is supposed to be allocated. So moving on, how we can release the block of memory in C. So using the functions malloc and calloc, we have seen how we can allocate the memory space during the runtime. Now we are going to see how you can release that particular memory space that has been allocated. Okay, so variable has been allocated. Okay, so now in normal time when we are trying to allocate the memory space in a static manner, so your variable has been allotted the memory space during your compilation time. So memory is being released with its storage class automatically once the program is getting executed. So this happens in your normal process, but when it comes to dynamic memory allocation, it is the responsibility of the programmer in order to release the memory space whenever the program has got executed successfully. So it is completely under the control of the developer or the programmer to release the memory space that has been allocated using the functions, that is malloc and calloc. Okay, so the syntax is we are going to make use of the function that is free, and we have to pass the pointer variable as an input argument. So let's say, for example, in the previous example, we have made use of array as a pointer variable. Okay, so whatever memory space has been allocated and that has been typecasted, okay, so that particular address is getting pointed to the array variable, that is array. Okay, so here if you see the syntax, p is actually the pointer of data type typecast. So this particular pointer variable has to be passed in order to release the memory space from your once the program has been executed successfully. Okay, so we have to pass the pointer variable as a input argument for the function that is free. So this will deallocate the memory space that has been already reserved using the functions malloc or calloc. Okay, so basically your pointer is created using the malloc or the calloc function. So we have to pass this particular pointer as an input argument for the function that is free. Okay, so this deallocated memory is again returned to the free list that is present in the heap. Always remember, your heap is actually the unused memory in your data memory. In your data memory, heap is actually your unused memory. Okay, so next we can see how we can alter the size of the allocated memory in C. So basically you might have allocated the memory space using the calloc or the malloc. Okay, so we are going to see how can you change the size of the memory that has been already allocated by malloc or calloc. So this particular alteration talks about the reallocation of the memory. So basically you are going to change the size of the memory. So the syntax is we are going to make use of the function that is realloc, and we have to pass the pointer p. So the same pointer has to be passed as the first input argument, and the second input argument will be the size of your memory allocation. So the new size has to present. Let's say, for example, I have already created a I have already reserved some memory space of size 10 using malloc or calloc. Let's say, for example, now I need to expand my memory. I need to change the memory size to 20. So I have to pass the pointer variable as well as the value that is 20 as a new size. So here's the syntax. I'm using an assignment statement, and this assignment statement in the right hand side, I'm calling the function that is realloc. And in the realloc, the first input argument will be the same pointer value that has been that is trying to get assigned in the left hand side. So you have to pass the same pointer variable that was used while creating the memory allocation using calloc or the malloc. So let's say, for example, this particular pointer already has a size 10, or I have actually created memory space of size 10 using malloc and calloc dynamically. Now what happens is I need to change the size. So the new size has to be passed as a second input argument for the reallocation function. So reallocation has got two input arguments, that is the existing pointer and then the new size that your memory space is getting required. Okay, so this particular value will again return me a pointer. So it allocates a new memory space of the size that has been specified, and then it returns a pointer to the first byte of the memory block. So it is something the same familiar functionality that we have already seen using malloc and calloc. Okay, so here you need not go for the typecasting. Why? Because already the typecasting has been done using the malloc as well as the calloc. So p is actually the pointer that is referring to the memory, and new size is the total number of bytes that you want to reallocate. Okay, so if you are trying to give the size value as 0, it simply means that you are trying to deallocate the memory, or it explicitly calls the function that is free. So which means you are trying to erase the memory location that has been available for the existing pointer. Okay, so this is something about how you can alter the size of the allocated memory in C. But there are certain scenarios. So let's say, for example, if already you have some memory space that is available in the old block of memory, then the same pointer will be returned by the realloc function. So which means I am having a particular memory location and I have changed the size, and there is a feasibility to expand that particular new size in the same block of memory. Then the old block of memory will be expanded, and then the first block of the memory address will be returned, which is the same pointer, If there is no such feasibility, then what happens is you have to copy the old data that is already available in the old block of memory, and then you have to move to the new block of contiguous memory. So remember, there are three scenarios actually. The first scenario is whenever there is a chance to expand the old block of memory, then the same pointer will be returned by the reallocation function. Okay, so the old block of memory is made larger or bigger, and then the same pointer value will be returned by the realloc function. So whenever there is no chance to expand your old block of memory, okay, then this particular function will return a new pointer. Okay, so what happens is you are going to make a copy of the old data to the new block of the contiguous memory, and because of this you are going to return a new pointer to the particular pointer variable. Then if there is no memory space that can be allocated as a result of your new request that has been given. So earlier I had a memory space of 10 that is available. Now I am going to give the new request as 100. I want to reallocate the size of this particular memory block as 100, and there is no chance to allocate this particular 100 memory space. Then this particular function will return a null pointer value. So basically there are three cases or three scenarios. Either the same pointer will be returned, or a new pointer will be returned, or a null pointer value will be returned. Okay, so next we will see the practical demonstration of the concepts whatever we have seen in terms of the dynamic memory allocation. So we are going to see the practical demonstration of dynamic memory allocation. So I'm just going to include my preprocessor directives. So I'm just including my preprocessor directive stdio.h, conio.h, and since we are going to make use of the functions malloc, calloc, free, reallocation, I'm just using the preprocessor directive stdlib.h. So I'm starting my main function definition. So here, let's say for example, I'm making use of okay, so I'm just going to make use of the number of elements that I want to make use, variable and integer variable for making use for the loop, and I'm creating one array variable. Okay, so remember here I'm trying to process an array, but the size of the array will be allocated dynamically during the execution time. So in normal process, what we used to do is we used to create an array of size 100 or 50, then we used to get the size from the user, but we are not going to do the particular process in this particular scenario where the memory is getting dynamically allocated. So what I'm going to do is I'm just calling the function clear screen, and I'm prompting the user to enter the size of my array. Or the number of elements that you want in the array. So the user will enter the value, and that particular value will be stored in the variable that is limit. Now what I'm going to do is I'm just trying to create the memory allocation. So as I told you, what we are going to do is we are just going to call the function malloc, and let's say for example limit is the number of elements that I want to have, and every element should have a size. So I'm going to make use of the size of function for the data type that is integer. So what happens is a memory space has been allocated. So let's say for example I'm giving the limit value as 4 or the size of the array as 4. So what happens is 8 bytes of memory allocation will be done for this particular scenario. So what happens is your malloc function, it will try to create a memory space of 8 bytes. So limit value has got the value that is 4, and size of integer data type has got the value that is 2. So 4 into 2 gives me a value of 8. So 8 bytes of memory space will be allotted, and this particular function will retrieve a pointer of void data type, and that particular data type should be typecasted. As we saw in the theoretical part, we saw that we are going to do a typecasting for this particular memory allocation. So this will be the syntax, how to create your memory allocation, and this particular value will be pointed to your pointer variable. So a is a pointer variable that we saw over here. Okay, so your a is a pointer variable, and that particular pointer variable will catch hold of the address of the first byte of your memory allocation. So now, so let's say for example, always remember you should have a check on the negative scenario as well. If this particular memory allocation is not possible, or if this particular memory allocation is going to return me a null pointer, then that null pointer should also be caught. This is just for a negative scenario, a failure case where a memory is not able to get allocated. That is, memory is not able to get allocated. Okay, so in that particular case you have to write the specific scenario of code, memory unallocated. So just a customized message can be given, and if you want to terminate the program, then you can make use of the function exit. You can make use of the function exit. So exit function will try to terminate your program. Okay, and it has to be given with the status of the, we have to pass the argument, okay, either an integer value of 0 or 1, just to indicate the status of the particular program. Okay, so this is syntax for calling the exit function. You have to pass an input argument, a numeric value of either 0 or 1, that will try to indicate the status of your program. So basically exit will try to terminate from the program. Okay, so if this condition is going to fail, so which means a memory space has been, if it has been allotted successfully, then this condition will not get executed. So we are going to the next part of the code, where we ask the user to enter the array values. Okay, so I'm just giving a printf statement. So I'm making use of a for loop, I value equal to 0, I is less than up to limit I plus plus. So now this is something very similar for you to get the array values. So we'll be making use of the pointer variable followed by, the address and then the pointer variable. So this is a normal process to get the array values, and then I'm going to print the list of array elements. Again, I'm going to make use of the same piece of code. So I'm just coming to the end of my main function definition. So I'm returning an integer value. I'm just trying to run this piece of code. So let's say for example I'm trying to enter the size of the array as 4. So 12, 23, 34, 45. So the array has been created with a size of 4 elements, and remember the memory allocation for these 4 elements has been done during the execution time, not during the compilation time. So here if you want to see the value of a, so let's say for example I'm just printing the value of a. So a basically will have the address, Okay, so remember A will have the address. So address is percentage U, and I'm just giving simply the value that is A. Okay, so the address is being created only after the dynamic memory allocation that is getting done for the array variable. Okay, so that's it. So it's a very simple example for doing the memory allocation using the malloc function. Now similarly, what I'm going to do is I'm just going to make use of the function that is calloc. So after getting the limit value, what I'm going to do is I'm just trying to call the function that is calloc, and here I have to pass two input arguments. One is the number of elements, that is the limit value, and then we have to see the size of integer. Okay, so and apart from that, I think what we can do is once the execution has been done successfully, what we can do is we can free the memory allocation for the variable. We can, so this what it means that we are going to deallocate the memory allocation that has been dynamically created by calloc. So here again I'm giving the value as 4, so the memory address has been created. So I'm just entering the array elements. So you can see the created array is 23, 34 and 45. So it's just a simple example. So we have seen the functions, that is malloc, calloc, as well as how to free the memory space as well. So now we will see how we can go for the reallocation of the memory allocation. Okay, so how we can go for the reallocation. So for reallocation, what we can do is okay, so here I'm just calling the function okay. So here once we have got the elements and I have displayed, so now what I'm going to do is I'm just trying to go for the reallocation. I'm just going to go for the reallocation. So here I'm making use of the same pointer variable A, and I'm just going to do the typecasting as well. Okay, so the typecasting has to be done, and what I'm going to do is I'm just going to call the function reallocation, and I'm just going to I'm just going to pass the value that is A, and I'm again going to get the value from the user. Enter the new size of array. Enter the new size of array, and this value is again got using the value that is limit. So again I'm going to give the limit value. So I'm going to repeat the same process. So I'm just going to copy paste this code after getting the new array value, after getting the new size of the array value. So initially I have created the array with the calloc. Now what I'm going to do is I'm getting the value from the user for the array, and I'm printing the list of array elements. Now I'm asking the user to enter the new size of the array, and I'm trying to reallocate the memory allocation. So I'm just going to alter the size of the memory size, and so again we can print the value of A. Once the memory has been created, what we can do is we can print the value of A just to see whether the old pointer value is getting retrieved or new pointer location is being given. So let's say for example initially I'm giving the size of the array as 4, so the address is changed to 2058. I'm entering the array elements, so the created array is given. So I'm now entering the new size of the array, so I'm giving the size of the array as 6. So it is pointing to the previous address only, but the thing is that in the existing old block of memory, the size is getting expanded. So previously when the size of the array was 4, now the new size of the array is getting expanded by 2 more, so it has become 6. So now I'm entering the array elements, third one, fourth one, fifth one, and then the sixth one. Okay, so the newly created array has got 6 bytes of memory, so that is 12 bytes of memory. So every element is of integer data type, so every element will occupy 2 bytes, so a memory space of 12 bytes will be created. So that is the concept of reallocation. So we have seen all the 4 functions that are used for allocating the memory dynamically during the execution of the program. So malloc, calloc, reallocation, as well as freeing the memory allocation. So if you have any queries related to this particular video, you can post your questions in the comment section. I thank you for watching this video.